Om Sri Sai Ram. Hearty welcome to Sri Sathya Sai Lok Seva Gurukulam for the chapter on gravitation. A very interesting topic, and this gravitation you are experiencing, not only we, all planets, satellites, birds, animals, all are influenced by this topic called gravitation. Let us just recall what you have studied in the previous class. The force of gravitation, the unseen force, which attracts a body towards the earth, which attracts the planets to sun, and so on. So this force of gravitation is there. We experience it, but we can't see it. And also we have studied what is called as Newton's law of gravitation. It is called universal law. We have studied, and the formula is F is equal to G into M1 M2, you can write, or MM by R square. Where F is called the force, it is measured by the unit called Newton, and G is called universal constant, it is measured by the unit called Newton meter square kg to the power of -2, and mm means mass of the two bodies. They are measured in terms of kilograms, or the distance between the two bodies, and it is measured in terms of meters. So Newton's law of gravitation says the force of attraction between two bodies is directly proportional to the masses, inversely proportional to the square of the distance between them, and it is equated by a universal constant called G, which is same everywhere. That is what you have studied in the previous class. Also, you have just closed the discussion about acceleration due to gravity. It is called acceleration because as the body approaches the earth, its acceleration increases, and its value is almost equal to, of course it varies from place to place, 9.8 meter per second square. And when you say gravity, there are two things here. One is for the bodies thrown upwards, another is for the bodies coming downwards. That we will see after some time. Okay. Also we have studied about Galileo's experiment. I think you enjoyed that figure. What is that figure called? Pisa. It is in a city called Pisa, and that building was Leaning Tower. What is the famous about that? It is one of the world famous towers, Leaning Tower of Pisa. And the experiment was two bodies of different masses were made to fall down from the same height. It was observed that they reached at the same time to the earth. So that is Galileo's experiment. Who was Galileo? He is a world famous scientist who gave a death blow to the so-called geocentric theory, where the people believed that earth is the center. But Galileo said sun is the center of the solar system. After discovery of telescopes. What is telescope? It's a device which shows maybe heavenly bodies or any bodies which is of a long distance, very near. Is it not? So this is already we have studied in the previous class. Now let us see some more interesting things today. Before that, we will answer the home assignment. The first question is, why do two students, in the previous class we said Ramu and Somu, sitting close to each other, do not feel the force of gravitational attraction between them? They are sitting near, but they don't feel it. Why it is so? Answer is, gravitational force is very, very weak. That's why they don't feel it. Only in the case of large masses. Here students, when you say it is 50-40 kgs, it's very small. But if the weight is more, then we experience that gravitational force. Is it not? And one more interesting thing I might have observed. Suppose you are coming down in a lift, about which you are going to study in the next class, about weightlessness. You experience a kind of thrill there. Even though you have weight, we don't experience it. That is because of the earth pulling down. All the bodies coming towards the center of the earth. So therefore, small masses do not attract each other due to this force. Second question, distance between two objects is increased by a factor of 4. That means R is made 4 times. How much will the change in the force of gravitation? We know the formula. Force of gravitation is proportional to mass of the two bodies, inversely proportional to square of the distance between them. Or you can say F is equal to G into M1 M2 by R square. Your question is, distance is increased by 4 times. Means R is made into 4 times the previous. How much will be the force? And as you know, it is inversely proportional. Force is inversely proportional to square of the distance. So if this is increased by 4 times, so that will be 4 square. So that becomes 1 by 16. So force will be reduced by 1 by 16 times if the distance is increased by 4 times. So here it means that as the distance between the two bodies decreases, force increases. If the distance between the two bodies increases, force decreases. So here, as it is increased by 4 times, the force is decreased by 1 by 16 times. That is the answer for this. Suppose instead of 4, if you have 3, it becomes 1 by 9. Suppose it is 2, double, then the force is decreased by 1 by 4 times. Okay, that is the answer for the second question. Coming to third question, why G is known as universal gravitation constant? Because the value of G is same everywhere, and it is called as, and it applies to all the bodies, maybe human beings, maybe animals, or any balls or any inanimate bodies. It is the same value. The G value will not change. That is why it is called as universal. It may be in case of planets, satellites, or stars, galaxies, and so on. The same law holds good. That is why it is called as universal law. And the constant is called universal gravitation constant, denoted by the symbol G. Coming to the next question. Why do heavier and lighter object when dropped from a same height fall at the same rate? That was a PISA experiment. Because the acceleration due to gravity is same for both heavy and light objects. The value of g, here the small g, you have to show. This is capital G, it is constant, but here it varies. Approximately it is 9.8 meter per second square. It is same for all the bodies, and it is independent of the mass, about which you are going to study after some time. Okay. Now today's topic, importance of the universal law of gravitation. What are the importance of that, or what is the application? The force that binds us to the earth. See, now you are sitting there, I am standing here, and all the bench, desk, everything is in the place, proper place. Table is in the proper place. All this is possible because of the gravitational force. So that is one application. Second is motion of the man around the earth. We run sometimes, we walk sometimes, we stand, we sit. All this is possible because of the gravitation. Motion of the planets around the sun. And what is this family called? The family of the sun and the planet are called solar system. Sun is the center, all the planets will be going around. How many planets are there? 8 planets. Is it not? Can you name them? Nearest to sun, what is it called? Mercury. Second one, Venus. Third one, Earth. Fourth, Mars. Fifth, Jupiter. Sixth, Saturn. Seventh, Uranus. Eighth, Neptune. There was one more actually, Pluto, but now it is not considered as a planet because it is away from the solar control of sun. That's why not taken. So all this is possible because of the gravitational force. And the tides which happen due to the moon and sun. The tides due to moon are called lunar tides, and the tides due to sun are called solar tides. So as a moon comes near, usually on the full moon day, moon will be very close to the earth. There will be more tides on that time. Similarly, on the new moon day, sun will be nearer and there will be more tides that time. So the distance of the moon and the sun as it approaches the earth has become nearer. There will be more tides, and these tides are due to the force of gravity. So these are some of the interesting applications of that. Now we will do a small activity. It was Robert Boyle, you might have heard about him. He is called the father of physics. Robert Boyle, he did a small experiment. He took a coin and a feather. This is a coin and a feather inside a bottle. Inside a bottle, and this is what is called as removing exhaust pump, removing air done by the exhaust pump. What he did was, he took a coin and feather in a glass bottle and he used a vacuum pump. So this is not exhaust pump, this is vacuum pump. What do you mean vacuum pump? Vacuum pump means which removes air. So air of the bottle, or it may be pipe also, is taken out. So when the air is taken out, the air is removed from here, then it becomes vacuum. When the bottle was inverted, both the coin and the feather hit the bottom at the same time. Even the feather is so light compared to coin. What do you expect? Actually, coin should come down first, then feather. But if the air is removed, then we find that both the coin and the feather come down at the same time. So that is the experiment done by Robert Boyle. So it also shows that the gravitation is independent of the mass of the substance. So acceleration due to gravity is the same for any mass given at a place. The SI unit of G is meter per second square. But the difference between A and G, A means that refers to the body which move on the plane surface, and G refers to that bodies which are thrown upwards or bodies which are thrown downwards or falling down. So that is the difference. So the value, the unit is same. Meter per second square is the unit. Okay. Now let us see the formula for acceleration due to gravity, that you call it as small g. So be clear about this. This is small g. The previous class we studied about universal constant, capital G. Here small g changes from place to place. So let the mass of the stone be m. Let us suppose that the stone is falling to the earth from a height. And let us suppose the acceleration due to gravity is g, meter per second square. The force be F. So we have the force can measure it in two ways. One, F is equal to mg. M means mass, g means acceleration due to gravity. So there is also force. But by universal law of gravitation it says F is equal to g into m by r square. The two bodies, m, let us suppose that is of the earth. Mass of the earth is, let us suppose, is m, capital M. The body is small m. R is the distance. G is called the universal constant. So both are forces acting on a body falling down. Okay. And now when you compare these two, so here R stands for distance, and you compare these two as the two forces. One is mg here, this is F, this is also F. Both are there acting on a body. Here to cancel m. So suppose you take capital M, you write it as capital M only. Capital M into m by r square. So the answer becomes capital M here. G into m by r square. Or if you take m1, m2, then it becomes m1 by r square. So here it refers to that the acceleration due to gravity is independent of the mass of the body. So this is G, formula for G, which you have to go into study now. And there are some interesting application of this. One of them is that acceleration due to gravity is independent of the mass of the freely falling body. Secondly, as the radius of the earth changes from place to place, the value of G also changes. What is the shape of the earth called? Shape of the earth is called geoid. Please note the name. geoid. What is the speciality of that? It is just like an apple. I draw a rough figure. So in apple you find, here is the center. These are called poles. So this center distance, the diameter, this is, let us suppose two poles, north pole and south pole. This distance is smaller than the distance between equator. This is what is called equator. What is equator? Equator is a imaginary line passing through the center. So here this diameter is less than this. Therefore value of G also changes. Here this will be less. Here this will be more. Okay, but average value is 9.8 meters per second square. Okay. And now let us write some equations. We have studied the equation under the body moving in a plane surface. We use the formula V is equal to U plus GT. This is for bodies falling down. Suppose a foot is falling down, or you might have seen in the night times meteors falling down. For bodies falling down, the formula is V is equal to U plus GT. That is called equations of motion. You have studied in the previous chapter. Yes, the distance travelled is equal to ut plus half gt square. Velocity v square is equal to u square plus 2gs. What is v? Final velocity. What is u? Initial velocity. What is g? Acceleration due to gravity. What is s? Distance travelled. For bodies thrown upwards, there is one more thing you must note. Suppose you throw a ball up. What happens to the equation? For the body is thrown upwards, same equation, the change of sign. V is equal to U minus GT. Instead of plus, you must write minus. Why you must write minus? Against gravity. Similarly, S is equal to ut minus half GT square. Similarly, V square is equal to U square minus 2GS. For bodies thrown upwards. Is it clear? So note the equations. Here instead of A, you use the symbol G. Okay. Here U is called initial velocity, V is called final velocity, T is called time, G is called acceleration due to gravity. So you can write it as V is equal to U plus or minus GT. S is equal to ut plus or minus half GT square. And V squared is equal to U squared plus or minus 2GS. Now let us see one example, one problem. Numerical problem, okay? A ball is thrown vertically upwards. Means what? Against gravity. Okay? Rises to a height of 122.5 meters. Calculate the velocity with which the ball is thrown upwards. Second, the time taken by the ball to reach the highest point. See, first of all, you must write down what are all the items given. Data, what do you call it? Now here the question is about ball is thrown upwards. So you must take formula with minus. And you must write all the initial velocity is 0 in this case. G is given. S is also given. S is nothing but distance travelled, means height. Using this data, we will work out this problem. Okay. G is given to be 9.8 meter per second square, and the solution distance S is equal to 122.5 meters. That is the final height it reaches. You should know, all of you experience that when you throw a ball, it goes to a last height, final height. From there it start coming down. Who will pull it out? There must be somebody, no? That somebody is nothing but Earth. That Earth has got what is called as acceleration. So here SC is 122.5. Final velocity means what? When the ball reaches the topmost position, that is final velocity, that V is equal to 0. Acceleration due to gravity is 9.8 meter per second square. So formula is V squared is equal to U squared minus 2GS. We have to find out U. Final velocity is 0 given. G is 9.8. SC is 122.5 meters. Now you have to find out U square. So U square becomes, if you multiply these three, it becomes 2401. So we get U is equal to 49 meter per second. So velocity with which the ball was thrown upwards is 49 meter per second. So velocity is meter per second, please note. And G is meter per second square. And next question was, what is the value of time to reach the maximum height? Formula is V is equal to U minus GT. U is 49, we have found out now. And minus G is 9.8. They are asking time T. So here you bring this side. So you get 9.8 T is equal to 49. And therefore T is equal to 49 by 9.8. It comes to, if multiply by 10, 49 into 10 is 490 by 98. It becomes 5 seconds. So time taken is 5 seconds. What is the meaning of that? The meaning is the ball reaches to the maximum height of 122.5 meters after 5 seconds. Okay, after that what happens? It starts coming down. And the velocity at the top is called V, final velocity. The velocity that was 0. And the velocity with which it started is called initial velocity, that is 49 meter per second. Is it clear? Okay, you work out this problem. First you copy down, then you, with closing books, you have to work out once again. Then you try some other problems on this same type. Let us see one more question about calculate the value of G. The mass of the earth is 6 into 10 to the power of 24 kgs. And radius of the earth is 6.4 into 10 to the power of 6 meters. Value of G is given to be 6.7 into 10 to the power of minus 11 Newton meter square kg to the power of minus 2. Applying the formula G into M by R square. So G is given to be 6.7 into the power of minus 11. And M is mass of earth. This is mass of earth. 6 into 10 to the power of 24 kgs by R square. R is, you can write small r also, capital R also, both are same. R is radius of the earth, 6.4 into 10 to the power of 6 square. Again you have to use the law of indices. What the law of indices says? First law, e to the power of m into e to the power of n is equal to e to the power of m plus n. Use that law. And here it is 10 to the power of minus 11. But here A must be same. Otherwise the law cannot be applied. Into a to the power of n means 24. So that becomes 10 to the power of 24 minus 11. How much it becomes? 10 to the power of 13, right? Similarly here, this is a to the power of m into power of n becomes a to the power of mn. That is 10 to the power of 6 square become 10 to the power of 12. I am telling about only powers I am discussing. But you have to multiply by 6.4 is also there. So here 10 to the power of 13 here, 10 to the power of 12 here. When you divide this, again one more formula. A to the power of m by a to the power of n is equal to a to the power of m minus n. Second law of indices. So m is 13, n is 12. So then you divide, it becomes 10 it becomes. Is it not? That is how you get this. And here you have to divide, multiply these two also, 6.76. And here is 6.4. If you multiply, it will be something like around 40 it becomes. Divided by 6.4, it becomes 9.8 meter per second square. You work it out, find out whether it is true or not. Okay. In science, everything is to be proved. Then only you should believe it was true. Acceleration due to gravity. Answer you must write. This is an answer for the question. 9.8 into 9.8 meter per second square. It need not be same. It may vary also. Okay. Now one more question we will see. The mass of the earth is 6 into 10 to the power 24 kgs. That the moon is 7.4 into 10 to the power 22 kgs. So which is more? Earth is more. This is 10 to the power 24. This is 10 to the power 22. Is it not? So find the distance between the earth and the moon. Sorry, if the distance between the earth and the moon is given 3.84 into 10 to the power of 8 meters. Something like 3,84,000 kilometers. Calculate the force exerted by the earth on the moon. Force you must find out. You are given with G, you are given with the M1, M2, you are given with R also. So direct formula, only question is about powers. So mass of the earth M1, 6 into 10 to the power of 24 kgs. Mass of the moon M2, 7.4 into 10 to the power of 22, mass of the moon. Distance between earth and the moon, about 3,84,000 kilometers or 3.84 into 10 to the power of 8 meters. And G value is 6.7 into the power of minus 11 Newton meter square kg to the power of minus 2. Apply in the formula F is equal to G into M1 M2 by R square. Or you can use it like this also, MM by R square. All are the same only. So write M1, you write capital M. That also you can write. There is no difference between that. Here G is, this is what is called G. This is the value. Into this is M1. That of the earth. What you taken from here. This is M2, that of the moon. But apply it carefully. By R square, this is distance. This is R. 3.84 into 10 to the power of 8 square. And if you simplify it, answer comes to be 2.01 into 10 to the power of 20. How do you get 20? See here. Again, same law you have to apply. 24 plus 22, 46 minus 11. 46 minus 11 becomes, so 10 to the power of 24 plus 22, there are plus items. 22 minus 11. It will be 10 to the power of 46 minus 11. That is 35, right? Yes. Here it is 10 to the power of 8 square is there. So 10 to the power of 16 it becomes. And when you multiply these two, your power will increase by 1. So you get 10 to the power 30, 10 to the power 36 becomes. 36 by 10 to the power of 16. That comes to 10 to the power of 20. You can do it yourself. No? First you have to multiply these 3 items. Multiply those 3. Then you take powers. Just shown now. Here also. Then you take this number separately. Then you calculate power. So this becomes 10 to the power of 35, the powers, into product of these 3. You find out how much it comes. Answer will be 2.01 into 10 to the power of 20 newtons. That is the force of attraction between Earth and the Moon. Okay. So that is the answer for that question. Now last point in this is the difference between mass and weight. In our usual terms, both mean the same in our day-to-day life. But actually there is a difference in scientifically speaking. So mass is the quantity of matter contained in a body. And it remains the same, very important. See, 1 kg of a substance here, say in Bangalore, weigh the same thing in Delhi. The mass becomes the same because particles won't change there. And it is measured by what is called as pan balance, also called as physical balance. What you see in the shops, there will be 2 pans and supported by a beam. Okay, this is the third difference. Fourth difference is the mass of an object is a measure of its inertia. More is the mass, more is the inertia. Okay, so these are the 4 important difference, or you can say points about mass. So this is the physical balance. Of course, there will be some more accurate also. So this is what is called pointer. And these are called pans. You have to put the weights, what you call it as made up of brass or made up of iron or steel, is kept on the right side. And the object is to be kept on the left side. This is what is called as pan balance. Here both of them are attracted by the same gravity, and hence it can be seen, the mass of the body can be seen by a pointer. Okay, this is the points about mass. Now coming to weight. Weight is nothing but the force with which the body is attracted towards the earth. And other day we have seen weight is equal to m into g. It is more than mass here. It is the product of mass and acceleration due to gravity. More is the mass, more is the weight. And more is the g value, acceleration due to gravity, more will be the weight. And this is the formula, F is equal to mg, that is about force when you say. And the same thing if you tell in terms of weight, it becomes W is equal to mg. The weight of a body changes from place to place depending on g. The g is more, weight also become more. It is measured by a device called spring balance. This is what is called spring balance. There will be actually graduations here. it is a hook here and the weight is to be kept on this and there will be a spring inside. If you pull this hook down, it shows the weight of the body. Nowadays it is measured in digitals also. This is a modern one. Used by digitals. You can see the weight by using digits there. It is advanced one. So, and last difference is weight has both magnitude and direction. The weight will be acting downwards. Here this is a downward force. Okay, mass is nothing but a product. Mass is nothing but the sum total of particles. Here this is the acceleration due to gravity for the given body. Okay, so these are the four differences between mass and weight. Okay, so we will close with the home assignment. The first question is, write the equation of motion under gravity for the bodies thrown upwards. Is it plus or minus? Minus. Falling down, that will be plus. The three equations you must write, which are shown. What is acceleration due to gravity? Write its SI unit. You can do it. State two factors with which the weight of an object depends. What will be the weight of an apple while it is falling from a tree? The right answer for that? Okay. Thank you. Sai Ram.